All right, hello, ladies and gentlemen. Let's go ahead and let's put together our thoughts about what we saw and what we explored today with the end behavior, okay? Hopefully you started to notice some patterns about what these functions looked like, and it all was based off of what we're going to call the degree of your polynomial and the leading coefficient. What do I mean by that? The degree is the highest exponent, the highest power of your polynomial, okay? So like with quadratics, they would have a degree of 2 because their highest exponent was always 2. That's what made them a quadratic, okay? The leading coefficient is the coefficient with the term that has that degree. So if I have a cubic function, something x to the third, whatever coefficient is with it, let's say it's a 2 or a negative 2 or whatever, that is the leading coefficient, okay? Well, why do I care about those two things? Well, hopefully you noticed that it all was based off of, the end behavior is all based off of those two things. You either have an even or an odd degree. So we have even over here, and we have odd over here, an even or odd degree. And then you should have noticed that something changed whether you had a positive or a negative leading coefficient. Okay, either a positive or a negative leading coefficient. Okay. With the even ones, okay, so let's start with even and positive. Okay, with the even ones, okay, you should have noticed that their end behavior went in the same direction. Okay, they were the same direction. When I go to the left, out towards the opposite infinity. When I go to the right, out towards infinity, my arrows went in the same direction. When it is positive, they both went up to the positive. Yay! Okay. In the middle, who knows what it does, right? The middle of the function, it could do a lot of different things. I'll draw this, okay, but it could have different bumps, could have whatever. But the end behavior, we know that it's both going to go in the same direction. If it's positive, they'll both be going up. If it is negative, they'll both be going in the same direction, down. So let's see, if we have even negative, our function's end behavior, both arrows will be going down, negative, okay, but in the same direction because it's even. And again, the middle of the function, who knows what it looks like. We could have a couple bumps. We could have anything. But the end behavior, we know, both going in the same direction because it's even, and because it's negative, leading coefficient, down. All right? Now, with the odd, you should have seen that the arrows went in opposite directions. Okay, your arrows went in opposite directions each time. Specifically, the positive in this case kind of tells you what the right arrow does. Okay? The right arrow is going to point up. The left arrow is going to point down, okay? And in the middle, who knows, could be going up, down, to the right, whatever, okay? But we're going to go up to the right, down to the left, okay? Odd, positive. Opposite directions, the right arrow goes up, the left arrow goes down, okay? Odd, negative, again, they're going to be going in opposite directions, but this time that right arrow is going to be headed down. It's going to be negative, while the left arrow is going to be positive. And again, who knows what's going on in the middle here? We could have a lot of jumps up and down. Okay, all we know is this is telling us what the end behavior is doing. As we go out towards infinity, blankety, blankety, blank, what's it doing, okay? So, these four things you need to know. These four, if you're even positive, even negative, or odd negative, okay? Are your arrows going the same direction? Even. Opposite directions? Odd. Is your right arrow going up? That's positive. Is your right arrow going down? That's negative, okay? Even positive, they both go up. Odd positive, the right arrow goes up, left arrow goes down, okay? Even negative, they both go down. And then odd negative, the right one goes down, the left one goes up, okay? And that's for every polynomial. All we have to do is look at that leading coefficient and that degree, and we'll know exactly what it's doing for its end behavior, what's happening at the ends. Thank you all for watching.